Hello everybody. In this week we will discuss about chapter 3 of the course Electrical and Electronic Equipment for Industrial Machinery. In this chapter we will discuss about three-phase AC circuits and electrical safety. The learning outcome of this chapter is LO 1.1. Understand the concept, term, quantity related to electric circuits. And LO 2.3 explain electrical safety principle. Now let's discuss about the basic three-phase AC theory. What is the three-phase power system? Three-phase power system is a system using three-phase source. Three-phase source is the combination of three single-phase sources, in which each voltage source have the 120 degree out of phase with each other. Three-phase power system can transmit more power with cheaper cost. Therefore, three-phase power system is widely used in the industrial revolution. Now, let's find how to generate a three-phase AC. Three-phase AC can generate by using the three-phase generator. An AC three-phase generator is simply three AC single-phase generator. Their generator runs sequentially with an offset of 120 degrees between them, taken two at a time. You can see in the figure, this is a three-phase generator. Now we will discuss about the second component. Let's denote the ABC is three-phase of three-phase power system. And we have the positive sequence. Positive sequence consists of parallel three-phase voltage and current phasor, which are exactly at 120 degrees apart, rotating counterclockwise in the ABC rotation. You can see in the figure. And the negative sequence consists of parallel three-phase voltage and current phasor, which are exactly at 120 degrees apart, rotating counterclockwise in ACB rotation. Remember, the positive sequence is ABC and negative sequence is ACB, and you can see in the figure. For the three-phase power system, we have two configurations, Y and delta. You can see in this figure show the Y connected three-phase voltage source, and this has four lines. A, B, C is the phase line, and N is the neutral lines. The phase voltage is the voltage between the phase and the neutral. You can see this formula. And the second one is the line voltage. It defines as the voltage between two phases. For the delta configuration, we don't have the phase voltage, we only have the line voltage, shown as this formula. And you can see in the figure is the Y connected three-phase voltage source. Now I will introduce the three-phase loss. Three-phase loss also have the two configurations, Y and delta. A three-phase loss is constant parallel when the total impedance of the load are equal. It means the load has the same impedance value, and the power factor of the load is equal. The connection between the three-phase loss and three-phase source have four configurations, Y and Y, Y and delta, delta and Y, and delta and delta. You can see in the figure show the Y source connect with the Y load. You can analyze this figure by using the Kirchhoff law and the Ohm law. For another connection circuit, Y delta, delta Y, and delta, you can use the Y delta transformation to convert it to the Y form. Now we will discuss about the power of three-phase circuits. For the true power of three-phase circuits is the sum of power of each phase. It means P three-phase equal PA plus PP plus PC. And reactive power is similar. Q three-phase equal QA plus QP plus QC. And for apparent power, is equal root square of P square plus Q square. This is the power of three-phase circuits. Now we will go to the electrical safety. Why the electric is danger? Electric current is capable of producing deep and severe burn in the body due to power dissipation across the body electrical resistance. And the electric current causes the muscle tetanus. The tetanus is the condition when the muscle involuntarily contracts due to the passage of external electric current through the body. When involuntary contraction of muscle controlling the finger causes the victim to be unable to let go an energized conductor, the victim is said to be frozen in the circuit. Diaphragm and heart muscle are also affected by electric current. The electric current causes the heart to flutter. DC is more likely cause muscle tetanic than AC, making DC more likely to place the victim into the shock scenario. AC is more likely cause the victim heart to fibrillate, which is the more dangerous condition for the victim after shocking current has been halted. Now let's discuss how the electric shock occurs. The electric shock occurs when the contact is made between 2 points of the circuit, when the voltage is applied across the victim body. You can see the person can safely rest on the high voltage power lines without getting shocked. Because they make contact with the circuit at only 1 point. Unlike the person touching a single wire is actually making contact between 2 points in the circuit, the wire and the earth ground. That's because the one side of our system usually connects to the earth ground. You can see in this figure is the path of current through the earth ground. Now we will discuss about the current through a body. It's not the voltage that's Q. It's current. It's the electric current that burns the tissue, frees muscle, and fibrillate the heart. However, the highest voltage is very dangerous. Amount of current through the body is calculated by using Ohm's law. I equal E divided R, which R is the body resistance. You can see in this equation, higher voltage, higher current. The body resistance is not fixed quantity. It varies from person to person and from time to time. The body resistance also varies depending on how contact is made with the skin. It is from hand to hand, hand to foot, foot to foot. The body resistance can vary from 1000 to 100,000 ohm. And this table shows the effect of the current to the human body. You can see with a 16 mA AC current, it makes the body painful and unable to let go of wire. Please careful when you work on the electric system. It's always safer to work on the circuit if you cut off the power of the system, but this is not always practical or possible. The best protection against shock from the light circuit is resistance, and the resistance can be added to the body through the using insulated tool, glove, boots, and other gears. Be aware, normal footwear is not good enough to provide the protection from the shock. Now we will discuss about a safe circuit design. Let's see a single 2-wire electric power system. You have the 2 conductors. The conductor connect with the ground is called the neutral or neutral line, and another conductor is called a hot line. Now let's discuss how to protect from the lost side. In the household electrical appliance, the wire conducting power from the element are insulated from the touching the metal case by rubber or plastic. It's a no shock hazard when it's operating properly. However, when the accident occurs, one of the wires inside the machine were to accidentally come in contact with the metal case. If the hot wire contact the case, it's very dangerous. But if the neutral wire contact the case, it's no danger. We have to some solution to protect the human if the hot wire contact the case. The first one is making the outside case of appliance non-conductive. It's double insulated. And the second one is use the third conductor to firmly connect the case to the ground. Now we will discuss about the rotation on the power supply side. In a properly functioning appliance, the current measured from the hot conductor should be exactly equal to current through the neutral conductor. But when the accident occurs, the hot wire accidentally contact the metal case. It will exceed the shock current through the person touching the case. The shock current will make the current in the hot conductor become larger than the current in the neutral conductor. And if we can detect the difference between the current, we can cut off the power. We can use the device called as GFCI, ground fault circle interrupter. It will be measure the difference of current, detect the current imbalance, and trigger opening of the disconnect switch, cut off the power. Now you know how to design the circle to protect the human from the electric shock. This is the last part of this week.